Maybe the universe is not silent. Maybe the message is being destroyed before it reaches us. At night, when the desert has cooled and the last heat has drained out of the concrete, the radio telescope looks less like a machine than an injury in the earth. A vast white dish lies open to the sky. Its ribs catch the faint starlight. Its cables hang like tendons. Its surface is turned upward, patient and exposed, as if the planet has tilted one enormous ear toward the dark and decided to wait. There is no music coming down, no voice, no sentence, no greeting from a distant intelligence, written in clean mathematics or repeated pulses, only the hiss of receivers, the breath of electronics, the endless trembling of data. The sky falls into the instrument as numbers, and the numbers fall into storage, and somewhere in that flood a human hope keeps looking for one impossible shape, a narrow line, a signal too clean to be natural, a bright thread in the spectrum where there should only be disorder. For decades, Earth has listened this way, quietly, repeatedly, with more discipline than romance. The public imagines a dramatic moment, a telescope turns, a screen flashes, scientists freeze, and the universe announces that we are not alone. The real work is colder. It is long hours of rejection. It is calibration, interference checks, software filters, suspicious candidates, and the steady killing of beautiful mistakes. Most of the sky sounds like nothing useful. Some things sound interesting for a moment. A spike appears. A line cuts through the noise. It seems to drift in frequency, just as a distant transmitter on a rotating planet might drift. It appears strong enough to raise the pulse. It has the shape of a question. Then the telescope looks away and the signal remains, or another telescope cannot find it, or the line turns out to be a satellite, or a piece of human technology, or a reflection, or a receiver artifact, or one more ghost made by Earth, pretending to be a star. The candidate dies, the silence returns. That is the rhythm of the search, not revelation, not failure in one clean stroke, a long, precise grief. The official truth remains intact. No confirmed extraterrestrial signal has been detected. No verified radio message from another technological civilization. No proven alien beacon. No hidden transmission waiting in a public database, with a simple label attached to it. The silence, as far as science can honestly say, is still silence, but silence is a dangerous word. It sounds complete. It sounds like a verdict. It invites the mind to imagine an empty galaxy, a vast dark theater where Earth performs alone. Yet silence can be made in many ways. A room can be silent because no one is speaking. It can also be silent because the wall is too thick, because the listener is deaf to the right frequency, because the speaker is too far away, because the words are swallowed by storm, or because the voice arrives so damaged that the listener calls it noise. The universe may be quiet, but it may also be violent. And a violent universe does not need to hide a message on purpose. It can ruin it by accident. The old dream of Radio SETI is elegant. If another civilization wants to be noticed, it might send a narrowband radio signal. Nature can produce radio emission, but natural sources often spread energy across wider bands. A signal squeezed into an extremely narrow slice of frequencies looks suspicious because it resembles engineering. It looks like someone took power and placed it with intention. It looks like a needle pushed through cosmic static. A narrowband signal is attractive because it is simple enough to search for. A telescope gathers the sky. Software cuts the data into tiny frequency channels. A search looks for a bright narrow feature that rises above the background and drifts, in a physically plausible way. The drift matters because planets and stars are moving. A transmitter on another world would not sit still relative to Earth. Its frequency would slide. The search has to follow the slide. This is difficult even in a perfect universe. But our universe is not perfect. The radio telescope does not sit above the world. It sits inside the world. Human signals leak everywhere. Satellites cross the sky. Radar pulses travel through the atmosphere. Aircraft, electronics, communication systems, and reflections from the ground can all create shapes that resemble something meaningful if the search is not careful. The telescope is not listening from a holy place beyond contamination. It is listening from a noisy civilization, searching for another noisy civilization, through its own electrical fog. Every candidate has to be treated like a suspect. Where did it come from? Does it appear only when the telescope points at the target? Does it vanish when the telescope moves away? Does it repeat? Does it show up at another observatory? Does it have a drift rate consistent with a distant source? Does it resemble known interference? Does it appear in more than one beam? Does it carry the fingerprints of our own machines? The more extraordinary the possibility, the harsher the interrogation. That harshness is not cynicism. It is survival. A field searching for intelligence beyond Earth cannot afford careless belief. A single overstatement will escape into the culture and become myth before anyone has finished checking the data. A weak candidate becomes contact. A technical anomaly becomes a message. A temporary line becomes proof. Science has to move more slowly than desire, so SETI has learned to say no, again and again. No, that was interference. No, that did not repeat. No, that did not come from the target. No, that is not enough. No, we do not know. No, we have not found them. The public hears the result as absence. The scientists hear it as boundaries. We searched here. We searched this way. We reached this sensitivity. We found no credible signal matching those conditions. That is not the same as searching the universe. It is not even close. The search space is not a dark room with one light switch. It is a wilderness of choices: frequency, bandwidth, power, time, direction, repetition, drift rate, signal shape, polarization, modulation, receiver sensitivity, telescope scheduling, target lists, algorithms, interference rejection, assumptions about what technology would look like at astronomical distance. Every search draws a map. Every map leaves blank regions. Something can exist in the blank. The most unsettling possibility is not that we have ignored an obvious signal. Serious search teams are not fools. The darker possibility is that the signal might not be obvious by the time it gets here. It might not be the clean needle we trained ourselves to notice. It might be wounded, broadened, weakened, and blended into the background by the physics of its own journey. A civilization could transmit. The signal could travel. Earth could receive its damaged remains. And our machines could reject it as noise. There is no conspiracy in that, no hidden file, no secret decoding, no shadow agency burying proof beneath a black marker. The story is colder because it needs none of those things. It needs only plasma, distance, stellar weather, thresholds, and the limited imagination of a search pipeline. A message can die without being murdered. It can die by becoming ordinary. Picture a world around another star. Do not make it too familiar. It does not need blue oceans or green continents. It does not need towers under a sunset, or creatures looking upward with faces like ours. All it needs, for the sake of this thought, is technology capable of producing radio emission. Maybe it is a deliberate beacon, maybe it is a radar system, maybe it is some industrial process that leaks narrowband power into space. Maybe it is not meant for us at all. At the transmitter, the signal is clean. Its frequency is concentrated. Its structure is sharp. It has the kind of artificial order that would make an astronomer on Earth lean closer to the screen. Then it has to escape its home. That word matters. Escape. We often imagine a signal leaving a planet and entering empty space, as if the space around a star were a clear hallway. But a star system is not an empty hallway. It is weather. It is magnetism. It is plasma. It is wind. It is eruption. It is radiation and charged particles and turbulence. Even our own sun fills the solar system with a solar wind. It throws storms into space. It shapes the heliosphere around us. It makes auroras shimmer at Earth. When particles interact with our magnetic field, the sun is not only a light, it is an environment. Other stars are environments too. Some are far harsher. Red dwarfs are small, cool stars, and they are everywhere. They make up a large fraction of the stars in the Milky Way. Their small size makes planets easier to detect. Their habitable zones sit close in, so a planet that might receive enough warmth does not need to orbit far away. To exoplanet hunters, red dwarfs are tempting because the signal of a planet crossing a small star can be easier to see, and a close orbit can make repeated observations more practical. But a world close to a red dwarf may live under a restless sky. Many red dwarfs are magnetically active. They flare. They can release bursts of radiation. Their stellar winds and magnetic fields can shape harsh space weather around close planets. A world in the habitable zone of an active red dwarf may be near enough to the star that space weather becomes a constant pressure, not a distant background. Now put a transmitter there, the signal leaves. It does not glide through a clean void. It passes through charged particles. It crosses magnetic structures. It moves through regions where electron density changes. It may encounter turbulence in stellar wind. It may pass through plasma disturbed by flares. It may be refracted, scattered, delayed, broadened, or made to flicker. Radio waves are not immune to plasma. They are shaped by it. Astronomers have known this in other contexts for a long time. Pulsars send pulses through interstellar plasma, and those pulses arrive dispersed, smeared, altered by the electrons along the path. Radio signals from spacecraft can fluctuate as they pass near the Sun. Compact radio sources can scintillate, their brightness changing because the medium between source and observer is not perfectly smooth. Plasma is not a passive emptiness. It is an invisible weather that radio waves must cross. The question becomes simple and terrible. Could the same kind of physics make a technological signal harder to recognize? Not erase it completely, not swallow it into nothing. Just damage the part we were looking for. If a narrowband signal broadens, its energy spreads over more frequencies. The total power may not vanish, but the peak becomes lower, the clean spike becomes a hill. The line becomes fuzzy. A search tuned to pick out extremely narrow features may lose sensitivity. The signal may no longer stand tall enough above the background to survive the automatic filters. The message is not gone in a philosophical sense. It is gone in the only sense that matters to a telescope. It fails to be noticed. The path from another world to Earth is not a poetic line through darkness. It is a chain of hazards. The signal has to be produced strongly enough. It has to escape the local environment. It has to propagate across interstellar space. It has to arrive during the hours we are looking. It has to land inside a frequency range we are observing. It has to be bright enough for our receivers. It has to avoid being buried under human interference. It has to fit the assumptions inside our software. It has to survive skepticism. At each step, it can fail. A signal can fail before anyone knows it existed. That is the hardest kind of failure to imagine, because it leaves no dramatic corpse, no broken antenna, no strange recording, no unresolved candidate celebrated in documentaries. Just one more region of data that never looked interesting enough. The archive grows, the silence remains, and somewhere inside the word silence, 1,000 different causes are buried together. This is why we heard nothing is a more complicated statement than it seems. A radio telescope does not hear in the human sense. It collects energy. Instruments convert that energy into digital form. Software organizes it. Algorithms search it. Humans interpret the survivors. Each layer decides something. Each layer throws things away. Some discarded things are interference. Some are noise. Some are bad data. Some are natural astrophysics. Almost certainly, nearly all of them are not alien technology. But if a real signal arrived in the wrong shape, it could enter the same graveyard, not because anyone is careless, because the graveyard is built by definitions. This is what every scientific search must do. It must define what counts. Without definitions, there is only chaos. But definitions are never neutral. They are tools. They cut the world into useful pieces. They make detection possible. They also make certain kinds of miss possible. A narrowband search is powerful because it focuses attention. It is dangerous for the same reason. If the universe preserves narrowband signals well enough, the strategy is beautiful. If the universe often scars them before they arrive, then the strategy still works in some cases but misses others. The problem is not that narrowband searches are wrong. The problem is that they may be incomplete in ways the silence does not reveal. A clean non-detection can hide a dirty path. Imagine the data screen. The background is black. A waterfall plot scrolls downward. Frequency stretches left to right. Time slides from top to bottom. Specks and streaks appear. Most are nothing useful, some are interference, some are statistical noise, some are known sources. A perfect candidate would draw the eye. A bright, thin track drifting in a way that makes physical sense. Now imagine that track blurred by turbulent plasma before it arrives. It does not become a dramatic explosion on the screen. It becomes less dramatic. That is why it is easy to lose. Its sharpness softens. Its contrast falls. It spreads. It becomes harder to separate from the background. It becomes less beautiful. Science is good at finding beautiful anomalies. Damaged anomalies are harder. A signal that looks almost like noise may be treated as noise because, most of the time, that is the right thing to do. If researchers kept every almost interesting smear, the search would drown in false positives. The galaxy is not the only noisy thing. The process itself becomes noisy. Data analysis must be ruthless or it becomes superstition. Yet ruthlessness has a cost. The cost is not known. That is the problem. How many signals would a search recover if plasma broadened them by a small amount? How many would survive if the broadening were larger? Which frequencies are more vulnerable? How much does the activity level of the source star matter? What happens around red dwarfs compared with quieter stars? Can signal broadening mimic natural or terrestrial interference closely enough to be dismissed? Can search pipelines be trained to detect weathered signals without opening the floodgates to meaningless noise? These are not alien contact questions, they are detection questions. Detection questions are where the real fear lives, because there may be no one out there. That remains possible. It may even be true. But if there is someone, the difference between knowing and not knowing may depend on a technical choice so small that no one outside the field would ever notice it. The width of a frequency bin, a threshold, a filter, a drift rate range, an assumption about what artificial should look like. The public imagination puts the fate of contact in the hands of civilizations. Will they speak? Will they hide? Will they be friendly? Will they be dangerous? Will they send a message across the void? But perhaps part of the fate of contact rests in something less dramatic. A signal processing decision made on Earth. A piece of code written to reject noise. A model of plasma that was not yet included, a telescope schedule that looked away too soon. A star flare that changed the medium before the signal escaped. A clean beacon turned into a dirty clue. This is not a comforting thought, it makes the galaxy feel less empty, but not more hopeful. Hope likes clear paths. This is a story of paths breaking down. It turns the search for intelligence into an engineering problem. Inside a weather system inside a cosmic ocean, Earth is not a central listener in a quiet hall. Earth is a small receiver in a violent galaxy. The Milky Way does not sit silently for our benefit. It hums with natural radio emission, it flashes. It erupts, it scatters, it absorbs. It contains supernova remnants, pulsars, jets, magnetized clouds, stellar wind, planetary magnetic fields, and human-made radio noise, rising from our own atmosphere. Against that background, a technological signal has to be not only present but recognizable. Recognition is a fragile thing. A face half hidden in fog may still be a face, but a machine trained only on sharp portraits may not see it. A word whispered through a wall may still be language, but a detector tuned for clean speech may call it static. A narrowband signal broadened by plasma may still carry the mark of technology, but a pipeline trained to worship narrowness may let it pass. The problem is not stupidity, it is mismatch. We search according to the shapes we expect. The universe may deliver damaged shapes. A mature science has to ask how its own expectations fail. That is not an argument against SETI. It is the reason SETI matters. The search is not only a hunt for another civilization, it is a test of our ability to think beyond ourselves without abandoning rigor. Too much imagination, and every anomaly becomes a fantasy. Too little imagination, and the search becomes a mirror, looking only for human-like technology under human-favored conditions. The narrow path runs between those failures. We have to imagine more possibilities than we can prove, then refuse to believe them until the evidence survives. That tension is uncomfortable. It should be. Any real search for another mind in the universe should be uncomfortable. The stakes are too large, the data too faint, and the human desire too strong. The galaxy has no obligation to protect us from our own wishful thinking. It also has no obligation to make discovery easy. A signal could arrive while we are not watching. Radio telescopes cannot stare everywhere at once. Even the strongest observing programs sample only pieces of sky, bands of frequency, windows of time. A transmitter could pulse once a year, once a century, once every 1,000 rotations of its planet. It could be aimed as a beam that rarely sweeps across Earth. It could operate at a frequency we do not prioritize. It could be turned off before our species invented radio astronomy. It could have passed Earth when trilobites lived in the seas, or when our ancestors were still making stone tools. Time is another form of noise. Distance is another, assumption is another. The silence is layered. A nearby technological civilization might be easier to detect, but nearby does not mean easy. A far civilization might be powerful, but power spreads. A deliberate beacon might compensate for loss, but only if they intend to be found. Leakage might exist, but it may be weak and undirected. Advanced civilizations might use tight, efficient beams that rarely leak. They may use communication methods that do not resemble our radio expectations. They may have outgrown noisy broadcasts. They may never have used them. They may be there and irrelevant to our instruments, or no one may be there. The honest answer keeps returning to uncertainty. But uncertainty does not have to be vague. Good science sharpens it. It asks which possibilities can be constrained, and which remain open. It does not say maybe as a hiding place. It says maybe as an instruction to measure better. Signal distortion by plasma is measurable in principle. Stellar activity can be observed. Red dwarf flares can be studied. Solar wind effects can be modeled. Known radio sources can teach us how propagation changes signals. Simulated technosignatures can be injected into real data to test whether search pipelines would recover them. The question can be brought out of speculation and into method. That is what separates this idea from conspiracy. A conspiracy begins with the conclusion and looks for shadows to protect it. Science begins with a vulnerability in the method, and asks how to test it. No hidden message is needed, no secret signal, no claim that aliens are trying to reach us. Only a more careful version of the search. What happens to a radio signal before it gets here? The answer depends on the environment. Around a quiet sun-like star, the path may be less hostile. Around an active red dwarf, the path may be more turbulent. During calm periods, the signal may remain sharper. During or after flares, it may broaden or fluctuate more. The effect may depend on frequency, geometry, distance from the star, plasma density, magnetic conditions, and the location of the transmitter. A civilization, if it wanted to build a beacon, might know this. It could transmit from an orbiting platform far from the worst plasma. It could choose frequencies less affected by its local environment. It could use high power, narrow beams, repetition, error correction, or other strategies to make the signal survive. The universe is harsh, but intelligence, if it exists, would not necessarily be helpless. That possibility matters too. We should not turn the galaxy into an unbeatable wall. The point is not that signals cannot reach us. The point is that detectability is conditional. A signal is not either present or absent in some simple human sense. It has properties, it has a path, it has a received shape. A search has sensitivity to some shapes and less sensitivity to others. A signal that is obvious under one condition may be invisible under another. The universe may not be hiding voices, it may simply be changing their shape. This is where the emotional weight of the story lives. We imagine communication as intention crossing distance. Someone speaks, someone hears, but astrophysical reality adds a third character: the medium. The medium can interrupt without meaning to, it can translate without understanding, it can turn language into static. It can make a beacon look like weather. The medium has no mind. That is what makes it terrifying. A hostile civilization would at least be a story. A silent civilization would be a choice. A dead civilization would be a tragedy. Plasma is none of those. It is indifferent. It is charged particles following physical laws. It does not know whether it is erasing evidence of another mind. It does not know that Earth is listening. It does not know that on a small planet around a yellow star, a species has built dishes and receivers and archives, and has begun to wonder whether the silence is real. Indifference is colder than malice. A star storm does not have to hate a signal to break it. The word storm is useful, but it can mislead. Stellar weather is not simply wind in the human sense. It is magnetic energy, radiation, charged particles, plasma structures, flares and eruptions. It happens across scales that make our storms look like breath on glass. Around active stars, the environment can change rapidly and violently. A radio wave crossing that region may experience conditions that vary with time and position. If the transmitter is on a planet close to the star, the signal's path through the local plasma may change as the planet orbits. At some orbital phases, the path might be cleaner. At others, it might pass through denser or more turbulent regions. A beam sent outward could carry imprints of that environment. The received signal might not be steady. It might widen, narrow, fade, flicker. To a search system, variability is both useful and dangerous. Useful because real astrophysical processes have patterns. Dangerous because variable signals are harder to confirm. A clean repeating signal from the same target is easier to take seriously. A variable, broadened, intermittent signal is easier to dismiss. It asks more work from the observer, it demands more data, it requires a model, it resists the simple thrill of a spike. The public remembers spikes. Science often advances through smears. The cosmic microwave background began as an unwanted noise in a receiver. Pulsars were strange repeating radio sources before their nature was understood. The history of astronomy is full of things that were inconvenient before they became obvious. That history should not make us gullible. It should make us patient with the possibility that meaningful signals may not arrive in the most emotionally satisfying form. Most anomalies are not revolutions, but revolutions often begin as anomalies. The difference is evidence. De Hente's burden is heavier, because the claim would be unlike any other. A new class of star is remarkable. A confirmed technological civilization beyond Earth would change the human story. The evidence would need to be severe. It would need independent confirmation, repeatability or overwhelming robustness, elimination of local interference, elimination of natural explanations, and a signal structure that can survive the hardest skeptical assault. A broadened signal is not likely to meet that bar quickly. That does not make it worthless. It means a future discovery, if one ever comes through this path, may begin quietly, not as an announcement, but as a class of suspicious cases that behave differently from known interference and known astrophysics. It may involve many observations across time, careful modeling of stellar activity, comparisons across frequency, and repeated attempts to make the signal disappear as a natural effect. Only if it refuses to disappear would the story grow. That is how science should work. The early stages would be maddening, a team might see a recurring mopbrod feature from a target star. The feature might change with frequency in a way that suggests propagation. It might not match local interference. It might appear when the telescope points at the target and vanish when it moves away. It might still have no obvious natural explanation. The researchers would be careful. They would not call it alien. They would call it a candidate, then a puzzle, then a target for follow-up. Other telescopes would look. Most likely, the signal would die. That is what usually happens. But if it did not, the tension would sharpen. The world would not need a dramatic decoded message. The scientific community would need something more demanding. A persistent anomaly with a structure that survives every attempt to make it ordinary. That is the only kind of wonder worth trusting. Wonder that survives hostility. Until then, the silence remains, yet even silence has changed. Once you understand how many ways a signal can fail, the dark no longer feels simply empty. It feels like a vast engineering problem, with no guarantee of success. The telescope is not merely waiting for someone to speak. It is trying to catch a fragile pattern after the galaxy has handled it roughly. The word here becomes almost arrogant. Do we hear the universe, or do we filter it? Do we listen, or do we classify? Do we encounter silence, or do we produce silence by discarding what does not fit? These questions do not accuse the scientists, they accuse the scale of the problem. Human beings have been radio astronomers for barely a breath of cosmic time. We are newcomers with excellent instruments and primitive expectations. We have learned a great deal, but the galaxy is old, and technology may be stranger than the early radio age taught us to imagine. Our own planet is a warning. Earth's radio signature has changed quickly. The era of powerful broadcast leakage may not last forever. Communications become more efficient. Signals move into cables, fiber optics, tight beams, digital systems, and localized networks. Radar emissions persist in some forms, but the technological noise of a civilization can evolve. A distant observer looking for Earth at the wrong century might see a different planet from one looking now. If our own detectability changes over a few human generations, why assume another civilization would remain detectable in one stable way for millions of years? The galaxy may be full of brief windows. Technological species could become radio bright for a time, then radio quiet. They could transmit beacons only during certain eras. They could leak signals unintentionally before learning to control them. They could shift to systems that hardly radiate into space. Their strongest emissions might be industrial, military, scientific, navigational, or accidental rather than communicative. A search for alien signals is also a search for timing overlap. We must exist while they are detectable, we must look while they are transmitting, the signal must survive. Our instruments must recognize it. Every condition narrows the doorway. That is why the absence of confirmed detection should feel sobering, but not simple. The doorway is narrow enough that silence is not shocking. It is expected under many scenarios, including scenarios where we are not alone. The silence may still mean emptiness. But it does not have to. That ambiguity is the engine of the search. At the edge of the radio telescope's dish, night gathers like water. The stars look calm because distance erases violence. A red dwarf flare 20 light-years away does not look like thunder from Earth. It is a data point, a brightening, a spectrum, an event recorded by instruments. The human eye sees serenity. The instruments reveal unrest. A galaxy can look peaceful while it ruins messages. The same sky that poets call silent may be full of destructive weather on scales too large to feel. A beam leaves a world. It is narrow, precise, artificial. It crosses a plasma region where density variations act like a distorting lens. Its phase is disturbed, its frequency structure changes, it emerges less clean, it travels for years, it spreads, it weakens. It reaches Earth as an almost feature, a low ridge under noise, a faint broadening across channels. The telescope records it, the pipeline examines it, It does not match the preferred shape, it falls below threshold, the signal is not rejected with drama. It is not rejected by a person leaning back and saying no. It never rises high enough to become a thing people discuss. It is treated as background, because background is what it resembles. That is how a message can vanish in plain sight, not by being hidden, by becoming statistically uninteresting. There is no more efficient grave than that. The universe does not need to silence itself. It only needs to lower the signal-to-noise ratio. Signal to noise. The phrase sounds dry until you realize it describes the boundary between history and nothing. If the signal is strong compared with the noise, it can be noticed. If it is weak, it may disappear. The difference may be a little extrastellar turbulence, a slightly poorer receiver condition, an interfering terrestrial source, a shorter observation, a wrong assumption about bandwidth. Humanity's knowledge of whether anyone else exists could depend on a ratio. That should humble every grand answer. The Fermi question asks, where is everybody? It is a magnificent question, but it can sound too social, as if the galaxy were a city, and the streets were empty. A better version may be harsher. Under what physical, technological, and observational conditions would anybody be detectable at all? That question has no easy drama. It is made of limits. Limits are not excuses. They are the architecture of the unknown. A telescope's sensitivity tells us what we could have heard. A survey's target list tells us where we listened. A bandwidth tells us what kinds of signals we allowed to appear. A search algorithm tells us which shapes we valued. A non-detection tells us only what survived none of those filters. If a signal dies in the noise, it does not leave a message saying it died. The silence looks the same. This sameness is the problem. An empty galaxy and a badly searched galaxy can produce similar data. A universe without nearby transmitters, and a universe with signals below threshold, can both give us nothing. A civilization that never sends radio and a civilization whose signal is broadened by plasma, both vanish from the same kind of survey. The telescope cannot tell us which story is true, unless the search is designed to separate them. So the answer is not to believe. The answer is to design better ignorance. That phrase may sound strange, but it is what good science does. It improves the shape of what we do not know. It replaces vague darkness with mapped uncertainty. It says we have ruled out transmitters of this strength, at this distance in this band, under this model. It says we remain blind to weaker, broader, rarer, intermittent, differently modulated, or more distorted signals. It gives ignorance edges. Edges are progress. The danger is emotional impatience. People want the silence to mean something immediately. Loneliness, rarity, cosmic danger, hidden life, a great filter, a zoo, a dark forest, a failure of imagination, a coming revelation. Human minds hate unresolved scale. We turn the unknown into mythology because mythology gives the unknown a face, but the search does not need a face. It needs patience. There may be no grand cosmic reason for the silence. It may be an accumulation of small effects: distance, timing, weakness, interference, search limits, signal choices, stellar weather, planetary environments, human assumptions. Each one reduces detectability. Together they may make a galaxy with some technology still sound empty to a young civilization like ours. That is not as cinematic as a single answer. It is more plausible than many single answers. Reality often defeats drama by being distributed. No one factor kills the signal. Many factors bleed it. By the time it reaches us, the line is faint. By the time the software sees it, the line is broad. By the time the threshold is applied, the line is gone. This is why the image of a dying signal matters. It is not a literal organism. It is not alive. But it has a birth, a path, and a failure. It leaves a transmitter with structure. It crosses a hostile environment. It reaches a receiver altered. It is measured but not recognized. It ends as noise. For a documentary mind, that is almost unbearably visual. A radio beam, thin as intention, moving through red light. A flare rising, from a star, like a wound opening. plasma tearing the beam into threads, the threads spreading, a telescope on Earth catching the remains, a screen filling with static, a line almost forming. Then nothing. No villain, no answer. Only physics. The hardest thing to keep in view is the scientific boundary. Nothing about signal broadening proves another civilization exists. Nothing about red dwarf flares implies a transmitter. Plasma effects are real, but a real effect on radio waves is not the same as evidence of alien technology. The universe is full of natural signals and natural distortions. Most noise is not a message. Most strange shapes are not intelligence wearing a mask. The boundary has to remain clear. Possible distortion is not detection. Meech limitation is not proof. Cosmic silence being complicated does not mean cosmic life is abundant. A more difficult search is not the same as a successful search. That clarity is what allows the idea to stay powerful. It does not need exaggeration. The fear is not that we found something and refuse to admit it. The fear is that we may not yet know how to find what would be there. If it existed, the difference is everything. Conspiracy says the truth is hidden by people. This says the truth may be hidden by physics. And physics is harder to interrogate than people. You cannot subpoena plasma. You cannot accuse stellar wind of deception. You cannot demand that a flare explain why it occurred at the wrong time. You can only model, observe, compare, and improve your instruments. That is quieter than conspiracy. It is also more frightening, because there is no one to blame. If a signal dies in the noise, no one has betrayed us. The universe has simply behaved like the universe. The same universe that allows stars to shine also allows their storms to interfere. The same electromagnetic laws that make radio communication possible also make plasma distortion possible. The medium that carries the message can damage the message. The possibility of contact contains the possibility of loss. At cosmic scale, communication is not a clean miracle. It is survival through physics. A civilization wanting to be heard would have to understand this. It would need to engineer around its star, its planetary environment, the interstellar medium, and the unknown receivers of unknown listeners. It would need to decide whether to send broadly or narrowly, continuously or intermittently, loudly or efficiently. It would need to choose a frequency. It would need to choose repetition. It would need to decide how obvious is too obvious, and how economical is too faint. If they are not trying to be heard, the problem is harsher. Leakage does not care about interstellar detectability. It is not designed for us. It may be weak, scattered and temporary. It may reveal a civilization only under very favorable conditions. A passive listener like Earth might need absurd luck. This is another reason silence is not a verdict. We may be searching for deliberate beacons in a galaxy where most technology does not beacon, or searching for leakage in a galaxy where leakage is short-lived. Or searching for narrow signals in a galaxy where local plasma broadens them. Or searching with tools that are excellent but still young. Every possibility makes the dark more complex. Some people find that disappointing. They want SETI to be simple, because simple searches offer simple hope. Build a bigger telescope. Listen harder. Wait. The signal will come. The real search is more difficult, and therefore more adult. It accepts that bigger telescopes are not enough if the signal's shape is misunderstood. It accepts that silence can be produced by instruments, as well as by the sky. It accepts that our own technology is both the basis of the search and a source of bias. We imagine alien technology through the shadow of our own. That may be unavoidable. But it should not be invisible. The narrowband idea is not arbitrary. It is grounded in real radio engineering and real astrophysics. A narrow signal is efficient and distinguishable. It remains one of the cleanest technosignature concepts. The question is not whether the idea is bad. It is whether the received signal would still preserve the feature that makes the idea useful. If a star's plasma environment takes a narrow line and makes it broad enough to lower detectability, Then the search needs to adapt, not abandon, narrowband, expand around it. Meach for wounded narrowband signals, look for broadening consistent with propagation. Build models of source environments. Treat active stars not merely as targets with planets, but as media that reshape outgoing waves. Ask whether a candidate's width and variability could carry information about the path. The scars might become clues. A damaged signal may tell us both that something transmitted and what kind of environment it crossed. That is a fascinating possibility, but also a dangerous one. Natural sources and propagation effects can create complicated shapes. The burden of proof remains severe. The more flexible the search becomes, the more false positives it may invite. The wider the net, the more debris it catches. Better listening is not simply looser listening. It is more informed listening. It knows the difference between opening the mind and opening the gate to nonsense. That distinction is essential. The universe is not short of weirdness. A search that calls every weird thing interesting will collapse under its own noise. The challenge is to define new kinds of interesting that are physically motivated, testable, and resistant to human wishful thinking. That is the future hidden inside this idea. Det tendi not as a single ear, but as a science of corrupted signals, a discipline that asks not only what might be transmitted, but what the galaxy does to transmissions. A search that understands the receiver is only the last chapter of the signal's life. Before Earth ever gets involved, the signal has already lived through its own world. It may have crossed an atmosphere, a magnetosphere, a near-star plasma environment, a stellar wind, interstellar space. It may have been delayed, dispersed, scattered, broadened, weakened and bent. When it reaches us, it is no longer a pure act of engineering. It is a collaboration between engineering and environment. Maybe that is why the clean beacon feels almost naive now. It is not impossible. It is not even unlikely as a deliberate design, but as an assumption about all detectable technology it is too tidy. The galaxy is not tidy, stars are not tidy, planets are not tidy. Civilizations, if they exist, will not be tidy. The signal may carry mess. Our search has to be ready for mess, without mistaking mess for meaning. That is the knife edge. The emotional version of SETI asks whether we are alone. The technical version asks whether we would know. The two questions are inseparable, but they are not the same. We could fail to know in a universe with others. We could search brilliantly, and still be too early, too limited, too local, too narrow, too unlucky. We could improve and still find nothing because there is nothing to find. The search does not guarantee comfort. It guarantees only that our ignorance becomes less lazy. That is enough reason to keep listening. The night sky above a telescope is full of ancient light, but a radio search is not only looking at the past. It is looking for technological time. A signal from 10 light-years away is 10 years old. A signal from 1,000 light-years away began before many human events now considered historical. A signal from across the galaxy could be older than civilization on Earth. Contact, if it ever happens, may not be a conversation. It may be archaeology by radio. A damaged signal makes that archaeology harder. Imagine finding a burnt manuscript where only the pressure marks remain. You cannot read it as a book. You have to infer that writing was there at all. You examine the fibers, the patterns, the ash, the shapes that remain. You do not call every stain a word. You do not call every blank page a tragedy. You work slowly, because the object is fragile and the conclusion matters. A weathered radio signal would be like that. Not a speech, a remnant. The difference between remnant and noise may be subtle. Subtlety is not what the public wants from aliens. But it may be what the universe offers. This is why the phrase, alien signal, can be misleading. It sounds too clean, too human, too dramatic. A real technosignature may not announce itself as alien. It may appear as a statistical excess, a persistent narrow feature, a strange infrared pattern, an unnatural atmospheric gas combination, a light curve anomaly, a laser pulse, or a radio shape that takes years to classify. The evidence may be distributed across instruments and models. The more serious the search becomes, the less it resembles the movies. That does not make it less grand. It makes it more frightening, because grandeur without simplicity is harder to hold in the mind. A giant radio telescope under a black sky is easy to understand. A signal dying in plasma turbulence is harder. Yet the hard version is where the real universe lives. The cosmos is not arranged around human narrative clarity. It is layered, messy, and indifferent to our preferred symbols. Maybe that is why silence has lasted so long, not because the answer is one thing, because the question touches too many things at once: life, intelligence, technology, stars, media instruments, algorithms, time, distance, luck. Every one of them can break the chain. For a signal to become a discovery, the chain must hold. The transmitter must exist. The signal must be emitted. The beam or leakage must travel toward us. The environment must not ruin it beyond recognition. The signal must remain strong enough. Earth must be observing. The telescope must be sensitive. The frequency must be included. The pipeline must search the right shapes. Interference must be ruled out. Natural explanations must fail. The signal must repeat or otherwise provide robust confirmation. The scientific community must be convinced. That is not a small chain. It is astonishing that we ever expected the answer to be easy. Still, the act of listening is not foolish. It is one of the most profound experiments a species can perform. It is cheap compared with the question it asks. It does not require belief. It requires discipline. It turns loneliness into measurement. It asks the sky to prove nothing, only to be observed with care. And when the sky gives nothing back, the experiment does not end. It becomes sharper. Which nothing? From where? Under which assumptions? At which sensitivity? For which signal shapes? The question, what if alien signals are dying in the noise, is not a claim. It is a pressure applied to the search. It forces us to look at the boundary where signal becomes background. It forces us to ask whether our definition of signal is too narrow. It forces us to imagine a universe where the difference between discovery and silence is not existence, but recognition. Recognition can fail quietly. The greatest failures in listening are not always loud. Sometimes they are built into routine. A pipeline does what it was designed to do. It rejects what does not match. It keeps the dataset manageable. It protects scientists from false hope. It is working correctly. And because it works correctly, it may discard what no one taught it to value. This is not a criticism of automation. Without automation, modern SETI would drown. The data volumes are too large, the interference too constant, the search space too vast. Machines are essential. But machines inherit our assumptions. They make our expectations fast. If expectations are incomplete, machines can miss at scale. That thought belongs not only to SETI, but to all of modern science. Instruments extend perception, algorithms shape attention. Models tell us what matters. The world enters through filters. Better filters reveal, bad filters erase. In fields where signals are faint and stakes are high, the filter becomes part of reality. A faint technosignature is not simply out there. It is out there plus the path, plus the detector plus the model. Leave out any part, and the thing disappears. This does not mean reality is subjective. The signal either exists or it does not. But detection is a relationship between reality and method. A planet existed before we discovered it. A pulsar emitted before we understood it. A signal could cross Earth before our search knows how to mark it. The universe is not waiting for our categories to become real. Our categories are trying to catch up. The category of noise is especially dangerous because it is necessary. Noise is everything that obscures, contaminates, competes and confuses. Thermal noise, instrumental noise, human radio frequency interference, natural background, random fluctuations, plasma effects, the sky's own restless texture. Without the concept of noise, no signal can be defined, but the boundary is not sacred, Noise is a word we use when something does not help the current question, charm the question, and some noise becomes data. That may be the fate of broadened signals. Under a narrow search, they may be background. Under a propagation-aware search, they may become candidates. Under a better model, their shape may matter. Under a deeper survey, their repetition may emerge, or they may remain noise. The point is not to baptize noise as meaning. The point is to keep asking whether the boundary was drawn in the right place. A galaxy full of static is not automatically a galaxy full of messages. But a galaxy full of static may still hide the occasional artificial remnant in ways that require more than a simple spike hunt. This is the scientific challenge. It is also the emotional one. There is a deep loneliness in searching for something that might not know you exist. SETI is not prayer, but it can feel like a ritual of patience. Instruments replace candles. Frequencies replace words. The night is watched with discipline. Nobody promises an answer. Nobody even knows what an answer would look like. A strong narrowband detection from a nearby star would be magnificent. A broad, damaged, hard-to-verify candidate would be agonizing. The latter may be more likely than the former in some conditions. That means the emotional future of SETI may be frustration, not revelation, years of ambiguous hints, better models, dead candidates, new searches, old data revisited, arguments about thresholds, quiet papers that barely reach the public, no dramatic proof, no satisfying silence either, a field living between no and not yet. This is hard for humans. We prefer stories with turns. Science often gives gradients. The signal does not arrive or fail in one dramatic instant. It fades gradually, it broadens gradually, it slips across a statistical boundary. Its meaning is not destroyed by explosion but by dilution. It becomes less itself until the search cannot distinguish it from the rest of the sky. Dying in the noise is not cinematic in reality, it is almost invisible. The cinematic part is what it means. Somewhere, perhaps, a transmitter fires, not for us, not necessarily toward us. It may be part of a civilization's ordinary life, a system that measures, scans, communicates, navigates, or announces. A beam escapes. The civilization may endure for thousands of years, or vanish before the signal reaches us. Their world may change. Their star may flare. Their machines may go silent. The beam travels on, bearing no intention anymore, only physics. By the time it reaches Earth, the beings who made it may be gone. If Earth misses it, no one in the universe knows. That is the loneliness beneath the loneliness. A message does not guarantee a listener. A listener does not guarantee recognition. Recognition does not guarantee understanding. The chain is fragile all the way down. SETI, at its best, is an attempt to strengthen one part of that chain. We cannot make other civilizations exist. We cannot make them transmit. We cannot calm their stars. We cannot move ourselves closer, but we can improve how we listen. We can widen the search without lowering standards. We can model distortion. We can observe more targets. We can share data. We can build instruments with greater sensitivity and cleaner interference rejection. We can search old archives with new eyes. Old data matters because the sky has already passed through our instruments. A signal that was not understood 20 years ago may still be recorded somewhere. The raw data may contain traces no one was prepared to search for. As algorithms change, archives can become new telescopes pointed at the past. There is something beautiful in that. The past is not always gone. If it was measured, a damaged signal that failed one generation's pipeline might be visible to another generation's model. That does not mean archives are full of hidden alien messages. It means data outlives assumptions. The more carefully we preserve observations, the more future science can ask questions. Older science did not know to ask. A telescope listens once, an archive can listen again. The universe may not repeat itself for our convenience, but data can be revisited. This is why careful skepticism and careful preservation belong together. A candidate may not justify a claim today, but its data should not be thrown into oblivion if it can help future methods. Most of it will remain nothing, but nothing, properly stored, is still a map of where and how we looked. The map grows, the blank regions shrink slowly, and the word silence becomes less lazy. One day perhaps, a survey will target an active red dwarf, and search not only for classic narrowband spikes, but also for features widened by plausible plasma conditions. It will incorporate stellar monitoring, so flares and activity states are known. It will observe at multiple frequencies. It will compare candidate widths with propagation models. It will apply strict interference rejection. It will demand repeatability. It will not announce aliens because a strange feature appears. It will follow these evidence. Maybe it will find nothing. Maybe it will find a new kind of stellar radio behavior. Maybe it will improve the search and still deepen the silence. That outcome would be valuable. If a proposed hiding place for signals is tested and found unimportant under many conditions, the search becomes cleaner. If it matters, the search becomes wiser. In both cases, the work moves from speculation into knowledge. The point is not to make the universe less silent by force. The point is to understand what silence contains. There is a moral discipline in that. Not moral in the sense of virtue signaling, moral in the sense of intellectual responsibility. When asking a question as large as whether other technological minds exist, we owe the answer more than excitement. We owe it precision. We owe it patience. We owe it the refusal to turn uncertainty into content too quickly. The universe will not become more honest because humans are impatient. A dark, quiet, scientifically serious SETI story is more powerful than a fake revelation because it respects the scale. It allows the unknown to remain unknown without flattening it. It gives fear its proper source, not aliens, but the possibility that reality is beyond our current listening. The fear is not invasion, the fear is mishearing. The fear is not that something is coming for us, the fear is that something may have passed by. Signal that died in the noise would not change Earth. It would not interrupt broadcasts. It would not light up the sky. It would not make governments respond. It would not give philosophers a new era. It would leave us exactly as we are, looking outward, hearing nothing, arguing about the silence. That is almost unbearable. The most consequential thing in human history could fail to happen because a line was too broad. This is why the question haunts the technical details. Bandwidth is not only bandwidth. It is the width of a doorway. Threshold is not only threshold, it is the height a signal must climb to become real to us. Interference rejection is not only cleanup. It is a judge that may be harsh enough to protect truth and blind enough to miss a damaged truth. The search for another civilization may depend on 1,000 such judgments. No single one feels cosmic. Together, they decide what kind of universe we are capable of detecting. That should change how we look at the telescope. It is not simply a giant ear. It is part of a much larger act of interpretation. The dish gathers, the receiver converts, the software filters, the scientist doubts, the community verifies, the public waits. At no point does the universe simply speak into human understanding. Understanding has to be built. The signal, if it comes, will not be pure revelation. It will be an object of labor, a piece of data dragged through suspicion. Maybe that is fitting. A discovery of another intelligence should not be easy. Easy discoveries can be processed too quickly. A hard discovery forces a civilization to become more careful before it becomes more amazed. Perhaps the long silence is training, not sent by anyone, not designed. Just the natural consequence of being a young species learning how to ask a cosmic question without losing its mind. The silence teaches restraint. It teaches that wanting is not evidence. It teaches that the sky is full of tricks. It teaches that instruments have limits. It teaches that every beautiful candidate must be doubted. It teaches that loneliness is not proof. It teaches that hope must survive being corrected. Now, perhaps, the silence teaches another lesson. Listening is not passive. To listen well, Earth must understand the violence between speaker and receiver. The old metaphor of a message in a bottle is too gentle. A bottle floats on water. A radio signal crosses plasma, radiation, magnetic fields, and time. It can be stretched by motion, diluted by distance, broadened by turbulence, buried by noise, and misread by machines. It is not a bottle, it is smoke crossing a hurricane, and we are trying to read the original fire. A red dwarf flare erupts. From a distance, it is a rise in brightness. Up close, it is a magnetic release with consequences. Charged particles, radiation, changing plasma conditions. A planet nearby may be bathed in harsh energy. Any radio signal leaving that neighborhood travels through a disturbed medium. The path itself becomes dynamic. The signal is no longer only a statement from a transmitter. It is a record of a storm. If the beam breaks apart, it does not mean the civilization failed. It means the environment joined the conversations. What reaches Earth is not the message alone. It is the message plus damage. The damage might be fatal, or readable. That is, the frontier. Can we read damage? Can we tell the difference between a natural broad signal and an artificial signal broadened by a natural medium? Can we identify patterns that should not appear from stellar processes alone? Can we combine target knowledge, stellar activity, frequency behavior, and repeat observations enough to raise suspicion without overclaiming? These are hard questions. Hard questions are where the field grows. The simple search says, find a narrow spike. The deeper search says, understand why a spike might not stay narrow. Both matter. A civilization sending a deliberate beacon might design it to remain obvious. It might choose frequencies less affected by plasma. It might transmit from far outside its star's dense wind. It might use enormous power. It might repeat patterns. It might even encode redundancy to survive distortion. A deliberate beacon could still be found by classic methods. But the galaxy may not be full of deliberate beacons. It may be full of accidental emissions, temporary technologies, practical transmissions, directed beams, and signal forms not designed for the comfort of unknown listeners. For those, the path matters more. The medium may not be accounted for. The signal may not be optimized for interstellar survival. We should be cautious about anthropomorphism in both directions. It is wrong to assume others would act like us. It is also wrong to assume they would act like movie aliens. Technology is constrained by physics, but not by our current habits. The space of possible technosignatures is larger than the handful most familiar to public imagination. That is why the search must be plural: radio, optical, infrared, atmospheric, artifact, waste heat, narrowband, broadband, pulsed, continuous, targeted, all-sky, nearby stars, galactic plane, known exoplanets, quiet stars, active stars, old data, new instruments. No single method carries the whole question. The silence from one method is not the silence of all reality. Yet radio retains a special power because it was the original dream and remains a practical one. Radio waves cross dust. We can generate them. We can detect them. Narrowband signals can be distinctive. The methods are mature enough to be rigorous. The challenge is not to discard radio, but to make the radio imagination less brittle. A brittle imagination breaks when the signal is imperfect. A flexible imagination adapts while keeping standards high. That is the kind of listening the future needs. A young civilization might naturally begin by looking for obvious signals. As it matures, it learns to search for less obvious ones. Not because it wants to believe more, but because it understands the universe better. It learns that stars have weather, that media shape waves, that instruments create selection effects, that non-detections are not all equal. Maturity in SETI is the ability to say both. Nothing has been found, and our search is still incomplete. Those statements do not contradict each other, they protect each other. The danger of saying only nothing has been found is that it can harden into premature despair. The danger of saying only the search is incomplete is that it can inflate into fantasy. Together, they form a disciplined tension. No confirmed signal. Still searching. Better questions needed. This tension is the correct emotional state, not certainty, not credulity, a dark patience. The telescope's dish turns slowly. The motors hum, the sky shifts, a target rises, a target sets. Data are taken. Most will never be famous. No one will write myths about the hours when nothing happened. Yet those hours are the search. A civilization capable of facing cosmic silence must be willing to spend years listening to nothing, without turning nothing into a story too soon. But stories matter because they guide attention. The story of the clean beacon guided attention toward narrowband searches. It helped make SETI technically concrete. Now another story may be needed alongside it, the story of the damaged signal. Not to replace the clean beacon, but to remind us that transmission is a journey through weather. This story has no alien faces, no secret messages, no final proof. Only a question sharp enough to reshape the search. What if the message changes before it reaches us? Once that question enters the room, silence becomes tech. Every red dwarf target carries not only the possibility of planets, but the behavior of its magnetism. Every search for a narrow line carries the shadow of broadening. Every archive of rejected data contains just failures, but records of what older assumptions could not use. The universe may still be empty of technological neighbors. But if it is not, their signals may not arrive in our preferred form. The thought is humbling because it denies human centrality. It says the universe is not only larger than us. It may be less compatible with our detection habits than we hoped. It says our instruments are magnificent but not magical. It says intelligence, if it exists elsewhere, does not automatically become legible. Legibility must be earned. The history of astronomy is the history of earning legibility from light. Stars were once points, then spectra, then chemical compositions, temperatures, velocities, magnetic fields, oscillations, planets, atmospheres. The universe did not change. Our ability to read it did. Radio SETI may follow the same path. At the beginning, we searched for obvious symbols of technology. Over time, we may learn to read subtle signatures, environmental distortions, and complex patterns. The universe may not give us simpler evidence. We may have to become better readers. That is a hopeful thought, but only in a disciplined way. Better reading can reveal more. It can also reveal that the page is blank. No method guarantees discovery. Expanding the search may deepen the silence. More sensitive instruments may find no one. Better models may show that distortion is not enough to hide plausible transmitters in many cases. The galaxy may remain quiet after every improvement. That possibility must remain, otherwise the search becomes faith. But a silent universe after a better search is a different silence from a silent universe after a narrow search. It is stronger knowledge. It tells us more. It narrows the unknown. It earns the right to be unsettling. Until then, the silence is partly unmeasured. The signal might not exist. The signal might exist and fail. The signal might exist and arrive wrong. The signal might exist and be rejected. The signal might exist outside radio altogether. Each path ends in the same public phrase, nothing found. Science must keep the paths separate. There is a small tragedy in the fact that the public will rarely see those distinctions. Headlines prefer certainty, no aliens found. New search finds nothing. Scientists expand, hunt. Mysterious signal explained. The subtlety disappears, but inside the work, subtlety is the work. A real scientist does not simply ask whether the sky answered. They ask how the instrument would have responded if a signal of a given kind had been present. They ask what could be ruled out. They ask what remains unconstrained. They ask what the pipeline would miss. What would we miss? Is one of the most important questions in science. It is also one of the least satisfying. It points not at knowledge, but at the shape of blindness. In SETI, blindness is frightening, because the object of the search is not merely physical, it is existential. Missing a faint molecular line is one kind of loss. Missing evidence of another technological mind is another. It would not only be a technical miss. It would be a missed relationship with reality. And yet, the search must proceed as if missing is possible. That awareness is what keeps it alive. A civilization that assumes it cannot miss has already stopped listening. The most dangerous silence is the silence we misinterpret as completion. The night sky has always tempted humans into projection. Ancients saw animals, gods, heroes, and omens. Modern people see loneliness, danger, destiny, and statistics. SETI adds a new projection, the hope for peers. Not gods above us, not monsters coming for, but others somewhere in the dark, who learned enough physics to leave traces. Maybe that hope is wrong. Maybe intelligence is a local accident. Maybe Earth is one rare flare of mind in a mostly mindless galaxy. That possibility is severe, but so is the opposite, that there are others, and the galaxy is so large, noisy, and poorly aligned that we pass through one another's eras without contact. Civilizations rising, listening, transmitting, fading, never knowing that others did the same. A universe full of missed connections may be lonelier than an empty one. In an empty universe, silence is honest. In a universe of missed signals, silence is failure, not moral failure, cosmic failure, a failure of timing, physics, technology, and distance. The idea that signals could die in the noise belongs to that darker loneliness. It says the absence of contact may not mean absence of others. It may mean contact is a much harsher physical achievement than our stories admit. To communicate across a room, you need a voice and ears. To communicate across a galaxy, you need a transmitter, a path, a medium, timing, alignment, energy, survival, detection, interpretation, and doubt. The room taught us the wrong intuition. Space is not a room, it is a filter. Every light year filters. Every plasma cloud filters. Every star wind filters. Every receiver filters. Every assumption filters. By the time a signal becomes a candidate, it has survived a universe of filters. That survival may be rare even if transmitters are not. This changes the way we imagine advanced civilizations. A truly advanced civilization might understand the filtering problem well. It might build enormous beacons that account for propagation effects. It might transmit in ways designed to be robust across the galaxy. It might use repetition, multiple frequencies, error-correcting patterns, or intentionally unnatural structures. It might make itself obvious enough that plasma broadening would not matter. If such beacons exist nearby, and we still find nothing, that matters. But we do not know whether such beacons are common, rational, desirable, ethical, safe, or culturally stable. A civilization may not want to announce itself. It may not care. It may be unable to afford the energy. It may have no concept of interstellar communication as a priority. It may be focused inward. It may be extinct. It may be listening like us. A galaxy of listeners would be silent. A galaxy of listeners whose signals also die in noise would be silent twice. This is where the dark mood deepens. Silence can be produced by caution. It can be produced by indifference. It can be produced by weakness. It can be produced by physics. It can be produced by everyone waiting. SETI tries to break that symmetry by looking anyway. There is courage in that, though it is not the dramatic courage of exploration ships and heroic landings. It is the quiet courage of staring into data that probably contain nothing, and refusing to make them more meaningful than they are. It is the courage to be bored by the universe for decades and still refine the question. Boredom is underrated in science. Most of the search for life beyond Earth is not revelation but boredom disciplined into method. Repeated observations, null results. Calibration, negative papers. Parameter constraints, false positives eliminated. Models adjusted. The public sees the occasional mysterious signal or exciting exoplanet. The field is built on everything that did not pan out. The silence is not empty work. It is a record of effort. And every effort teaches where the next miss might happen. Stellar space weather adds another layer to that record. It tells us that target stars are not interchangeable points. A planet around a quiet star and a planet around an active red dwarf do not present the same propagation environment. The local conditions of a hypothetical transmitter matter. That means, target selection may need to account, not only for habitability, distance, and known planets, but also for the medium through which signals would escape. A star is not just a lamp for life, it is a gatekeeper for communication. That phrase has weight. Gatekeeper, not intelligent, not intentional, but decisive. The star gives energy, the star shapes climate, the star affects atmospheres. The star drives space weather. The star may help create the conditions for life, and then interfere with evidence of technology. A red dwarf can make planets easier to find and signals harder to preserve. The galaxy is full of such trade-offs. Our instruments make some things easier to detect and others easier to miss. Small planets around small stars are easier to see by transits, but close-in environments may be more active. Narrowband signals are easier to distinguish, but broadening can make them less narrow. Strict filters reduce false alarms, but may reduce sensitivity to unexpected shapes. Every advantage has a shadow. Science advances by naming the shadows. The shadow here is clear. A signal optimized in theory may arrive unoptimized in practice. The thin line may not stay thin. The receiver may be listening for a perfect wound, while the universe sends only scars. There is no need to make this mystical. The physics is enough. Plasma turbulence can redistribute power. Scattering can change apparent structure. Motion can drift frequency. Distance can weaken intensity. Interference can overlap. Noise can obscure. The combined result may be a signal that exists in a mathematical sense, but not in a practical one. Practical existence is what counts for discovery. A civilization beyond detection is indistinguishable from no civilization to us. That is a harsh epistemic fact. It does not mean the two realities are the same. It means our evidence cannot separate them. We live inside the limits of separation. The universe may contain truths that are real but unreachable. The search for technosignatures is an attempt to push back against that unreachable region. How far can it push? No one knows. That is why every improvement matters. A new receiver, a wider survey, better radio frequency interference mitigation, more continuous monitoring, more precise stellar activity data, better models of propagation, more open archives, more collaboration between radio astronomers, plasma physicists, exoplanet scientists, and signal processing experts. SETI cannot be only a romantic question anymore. It must be interdisciplinary because the signal's life is interdisciplinary. Engineering creates it, astrophysics alters it, instrumentation receives it, statistics judges it, human culture reacts to it. Every stage can fail. The old loneliness of SETI was the possibility that no one answered. The newer loneliness is possibility that the answer is too transformed to count. A radio telescope listens. Data pour in. The screen shows static. Somewhere behind that static, in the most cautious and limited sense, there may be no one, or there may be a signal buried below recognition. The data alone, without better models, do not tell us which story is true. That is why the telescope looks almost tragic under the stars. It is powerful, but not omniscient. It is sensitive, but not wise by itself. It can receive waves from across unimaginable distance, yet the meaning of those waves depends on everything built around it. A dish cannot know what to want. Humans decide. And humans are new. The human species has spent most of its existence under the sky, without knowing that stars are suns. We learned radio only recently. We began listening for technological life almost yesterday, by cosmic standards. Our instruments are astonishing, but our experience is shallow. A galaxy that has been forming stars for billions of years is being questioned by a species with a century of radio habit. There is comedy in that. There is also dignity. We begin where we can. A child listens at a door, and cannot tell whether the house is empty or the walls are thick. The correct response is not to invent voices. It is to learn how walls work. That is what the damaged signal idea demands. Learn how the walls work. The walls are made of plasma, magnetic fields, turbulence, distance, instrument noise, human interference and assumptions. Some are physical. Some are technological. Some are cognitive. All stand between a possible transmitter and certainty. The most deceptive wall may be the one inside the search itself. The expectation that artificial means clean. Human technology often produces clean signals, but not all technology does, and not all clean signals remain clean. If the search treats cleanliness as the dominant sign of intelligence, then cosmic weather becomes a source of invisibility. The answer is not to stop valuing cleanliness, it is to understand how cleanliness decays. A damaged narrowband signal may have a family resemblance to its original form. It may still be narrower than many natural sources, but broader than the ideal search window. It may show drift, it may show modulation, it may repeat with changes. It may be detectable with methods tuned for intermediate widths. It may need longer integration or different statistical treatment. These are technical possibilities, not promises. But they open a path is enough. The history of exploration is not the history of knowing where treasure is. It is the history of building methods that make unknown things findable. SETI is not looking for treasure, it is looking for evidence of mind. That evidence may be subtle. It may require us to stop thinking of messages as pristine objects, and start thinking of them as signals under stress. Stress reveals structure in materials. Maybe it can reveal structure in transmissions. A signal distorted by plasma might carry patterns that distinguish it from random noise if the underlying transmission has coherence. The challenge is separating that coherence from the distortion. Too little sensitivity, and it vanishes. Too much freedom in the model, and anything can be fit. The line between insight and self-deception is thin. That line is where the work belongs, not on talk shows. Not in sensational headlines, in careful, hostile analysis. The best SETI result, before detection, may be a more rigorous understanding of what we would miss. It sounds modest, but it is profound. To know the limits of hearing is to hear more honestly. To know how a signal can die is to stop treating silence as simple. The universe may still be silent, but we will at least know what kind of silence we measured. There is a strange comfort in precision, even when the subject is loneliness. A vague silence feels like abandonment. A precise silence feels like unfinished work. It says, "We have not heard this kind of signal from these places under these conditions." It leaves room for future questions, without filling that room with fantasy. That is the proper emotional temperature. Cold enough to avoid delusion, warm enough to keep listening. The radio telescope is still turned upward, the galaxy is still there, the data still arrive. Most of them are still nothing. Somewhere in the search, a student may write code that handles broader candidate features. A team may model how signals escape active stellar systems. A telescope may observe a red dwarf during different activity states. An archive may be reprocessed. A false lead may teach something useful. A better limit may be published. Another silence may become more precise. This is how the question advances when the sky does not answer. Not through spectacle, through refinement. Every refinement changes the meaning of "we can't hear it." At the beginning, that phrase sounds like despair. Later, it becomes diagnostic. Why can't we hear it? Is there anything to hear? Are we looking in the wrong band? Is the signal too weak, too brief, too broad, too rare, too distorted, too humanly imagined? Each answer opens another door. Some doors lead nowhere. That is acceptable. A serious search must be willing to open doors that reveal empty rooms. But it must also be willing to admit that the house is larger than the room already searched. The Milky Way contains hundreds of billions of stars. We have confirmed thousands of exoplanets and inferred that planets are common. The leap from planets to life is unknown. The leap from life to intelligence is unknown. The leap from intelligence to detectable technology is unknown. The leap from detectable technology to our detection is unknown. Each unknown multiplies the others. People often compress all of that into one question: are we alone? The compressed question is beautiful, the expanded question is terrifying. If life exists, does it become technological? If technology exists, does it radiate? If it radiates, does it use radio? If it uses radio, is the signal strong enough? If it is strong enough, does it travel toward us? If it travels toward us, does the environment preserve it? If it reaches us, do we observe at the right time? If we observe, do we recognize it? If we recognize it, can we prove it? A single no anywhere in that chain gives us silence. That is why silence cannot be read too quickly. There are too many ways to arrive at it. A philosopher might say this makes the search hopeless. An engineer would not. An engineer sees a chain and asks which links can be strengthened. The transmitter is beyond our control. The existence of life is beyond our control, but observation, modeling, sensitivity, interference rejection, and search strategy are not. Those can improve. The human role is not to demand a signal, it is to reduce the ways we would miss one. That is an achievable form of humility. The Earth has been leaking radio for a short time. It has been intentionally listening for an even shorter time. In that brief era, we have already learned that the universe is more complicated than the early dream. Exoplanets are common. Planetary systems are diverse. Some worlds are unlike anything in our solar system. Stars have personalities. Red dwarfs can be active. Habitable zones are not simple comfort rings. Atmospheres can be stripped, transformed, or protected. Space weather matters. Why would technosignatures escape this complexity? They would not. The search for life has matured from looking for Earth twins to studying planetary context. Search for intelligence may need the same maturation. A signal is not just a signal, it belongs to a system. Its detectability depends on that system: torrid star, planet orbit, stellar activity, transmission environment, propagation path, observing method. This system's view is less romantic than the old cosmic phone call, but it is richer. It treats a possible civilization not as a disembodied voice, but as technology embedded in astrophysics. That is almost certainly closer to reality. Every technology exists somewhere. Somewhere has weather. Weather changes signals. The story tightens around a simple image. A radio beam trying to leave home. It rises from a world under a red sun. The world may be barren or alive. We do not know. The transmitter may be a beacon or an accident. We do not know. The beam is narrow. It enters a region of disturbed plasma. A flare has stirred the star's environment. Magnetic fields twist, electrons shift, the beam scatters, its energy spreads, the line weakens. Years later, Earth listens, a telescope records a faint, broad feature. It is not enough, the feature sinks into the statistical dark, no one celebrates, no one's. The beam has completed its journey and failed to become evidence. This imagined story may never have happened. That matters. It may be only a warning, not an event. But warnings have value when they reveal blind spots. No one needs to claim that the galaxy is full of dying signals to ask whether our methods can detect them. If they exist, the question is testable enough to be respectable. That is all science needs to begin. A dark idea becomes useful when it produces better experiments. The experiment might be simple in concept. Take synthetic narrowband signals. Pass them through models of plasma. Broadening expected in active stellar environments. Inject them into realistic telescope data, with real noise and interference. Then test whether existing pipelines recover them. Vary the frequency, width, drift, strength, turbulence assumptions and stellar conditions. Ask where recovery fails. Ask which changes improve it without overwhelming the search with false positives. This kind of work does not produce dramatic headlines. It produces sensitivity maps. Sensitivity maps are the quiet anatomy of discovery. They tell us which signals would live and which would die. Once you know that, the silence becomes less mysterious in some regions and more mysterious in others. You can say, a signal like this would probably have been seen. A signal like that would probably be missed. The cosmic question becomes less fog and more landscape. A landscape can be crossed. Slowly, no one should pretend this guarantees contact. The landscape may lead to empty fields, but a search that understands its own blind spots is stronger than one that does not. The absence of confirmed signals becomes more meaningful as the search becomes more complete. If the galaxy remains silent after broad, deep, propagation-aware searches across many technosignature types, then the silence gains weight. It begins to say something stronger about the rarity of detectable technology, or the behavior of civilizations, or the difficulty of interstellar visibility. But we are not there yet. We are still learning how to listen. That sentence is less satisfying than we are alone, or they are out there. It is more honest than both. The universe may punish honesty with silence. It often does. But honest silence is better than false music. The temptation to hear what we want is ancient. Static can become voices if the listener is lonely enough. Patterns can become messages if the mind is desperate enough. SETI must resist that temptation every day. It must protect itself from human pattern hunger. It must remember that the sky is not obliged to make our hopes true, but the opposite temptation also exists. The temptation to let repeated silence become intellectual laziness. To assume that because we did not find the obvious thing, there is nothing subtle to find. To treat our present filters as if they define reality. To confuse the failure of one search shape with the failure of all possible signal forms. Both temptations are human. The mature search refuses both. It says, most noise is noise. It also says, let us learn what a damaged signal would look like. That balance is rare. It is quieter than belief, and more restless than skepticism. It lives in the uncomfortable middle, where the best science often happens. Imagine the control room again. The screens glow. Someone watches the waterfall plots. The data are not beautiful to the untrained eye. Bands, dots, streaks, noise floors, flagged regions. A human-made signal flashes through and is discarded. A known source is ignored. A candidate appears and fades. The night outside remains black. Nothing happens. Nothing happening is most of the work. But inside the machines, the definition of nothing may be changing. That is where progress hides. Not in the sky suddenly becoming generous, but in our categories becoming less crude. A civilization far away, if one exists, cannot help us find it unless it deliberately tries. Even then, physics may get in the way. The responsibility for recognition rests partly with the listener. Listening is an active moral and technical act. It requires care, humility, and a willingness to revise the meaning of noise. Noise is not the enemy exactly. Noise is the condition. Without noise, detection is trivial. With noise, science begins. The signal has to be defined against it, extracted from it, judged through it. The noise is not just obstruction, it is the medium in which evidence must appear. Maybe that is why the thought of dying signals is so powerful. It does not place the signal outside the noise, waiting to be found like a coin on a table. It places the signal inside the noise, wounded and disguised. Requiring a more intelligent listener, the search for extraterrestrial intelligence may demand intelligence from the search itself. Not just computational power, judgment, a deep understanding of how nature imitates, destroys, distorts, and hides, a refusal to call every shadow a person, a refusal to assume every shadow is empty. The galaxy may never reward that effort. There is no promise in the stars. But the effort changes us. It makes Earth less provincial. It forces us to see our planet as one receiver among many possible receivers, our technology as one phase, among many possible technologies, our assumptions as temporary. A species that listens carefully becomes different from a species that only shouts. So far, Earth has mostly shouted by accident and listened on purpose. That contrast is revealing. Our own radio leakage was never designed as a cosmic introduction. Much of it is weak, messy, and fading into technological history. If another civilization is searching for us, it may face the same questions we face. Is Earth loud enough? At which frequencies? During which era? Through what solar and interstellar conditions? With what search assumptions? To them, we may already be a missed signal. The thought reverses the loneliness. We are not only the listener who might miss them. We may be the signal they miss. Earth's own presence in the galaxy is not obvious. The blue planet feels enormous to us because it is everything we know. From light years away, it is a pale point, then no point at all without the right instrument. Its radio leakage thins. Its technological signature depends on method. Its life may be detectable in atmospheric chemistry, before its intelligence is detectable in radio. Its intelligence may be invisible to a search optimized for some other kind of technology. We are already evidence that a technological world can be hard to detect. We should apply that humility outward. The idea of cosmic silence often carries a hidden arrogance. If others were there, we would know. But would we? We barely know how we ourselves would appear. We are still modeling Earth as an exoplanet, still debating biosignature ambiguities, still refining technosignature concepts. We have not earned confidence in cosmic detectability. Confidence must come later. If at all, for now, the better emotion is vigilance, vigilance against false positives, vigilance against false closure. The sky is not silent in the way a dead object is silent. It is active, noisy, dynamic, and hostile to easy interpretation. A signal from another intelligence would not arrive in a sacred vacuum. It would arrive as one more physical process among countless others. To find it, we must understand the others well enough to know when something does not belong. That task is enormous. It may outlive everyone alive today. A civilization can still do it, not because it is easy, but because the question is worth more than a lifetime. Long-form science, the kind that sits with a question instead of harvesting a headline, exists for this reason. It can hold the unease, it can show the telescope, the noise, the flare, the beam, the failed candidate, the archive, the threshold, the silence. It can let the audience feel that the absence of proof is not the end of mystery, and that mystery is not permission to lie. The universe may be speaking, the universe may be silent. The message may be dying, or there may be no message to die. The only honest response is to keep the distinctions sharp while the search continues. There is a kind of terror in sharp distinctions. They deny easy comfort. They do not allow the believer to say we have found them. They do not allow the cynic to say the search is meaningless. They leave us with work. Work is less glamorous than revelation. It is more durable. Another night, another target, another red dwarf, another stream of data. Somewhere in the control room, coffee goes cold. A receiver hums. A plot updates. Human-made interference is flagged. A suspicious feature vanishes. A report is written. A non-detection joins the literature. The world outside barely notices, but the search has learned something a little more about where silence is real. A little more about where it is only untested. A little more about how noise eats meaning. The phrase alien signals is almost too bright. It draws the mind toward beings, intentions, civilizations, faces. Perhaps the better phrase for now is recoverable technosignatures. Colder, uglier, more precise. Not whether someone speaks, but whether anything technological can be recovered from the mess of astrophysical and instrumental reality. Recoverable, that word matters. A signal that cannot be recovered is not evidence for us. It may have crossed the galaxy and still be lost. It may have carried a pattern that no one ever read. It may be part of a universe richer than our data suggest, while remaining scientifically unavailable. There are truths that may never become evidence. Science lives by evidence, so it cannot claim them. But it can try to reduce the number of truths that remain unreachable. This is one reason SETI deserves seriousness, even without results. It is not merely waiting for aliens. It is developing the science of detectability at the edge of the possible. It asks what technology would look like across interstellar distance, how nature might imitate it, how nature might hide it, and how humans might separate signal from wish. That is a profound scientific project even in silence. The telescope does not know any of this. It does not know red dwarfs from loneliness. It does not know that humans have given the night emotional meaning. It only receives. A wave arrives, or does not. A line appears, or does not. A feature survives, or does not. Meaning comes later, if it comes at all. Maybe that is why the image of the telescope is so powerful. It is both magnificent and helpless. It can collect what no human sense can touch, but it cannot decide what matters without us. It is a machine built from longing and skepticism, two forces that rarely live comfortably together. Longing built the question, skepticism keeps the answer honest. Between them, the search continues far away, red stars flare. Plasma moves, signals from natural sources cross space. Human satellites streak overhead, receivers warm and cool, algorithms sort, data centers store, papers appear, candidate lists shrink, the silence remains, but not unchanged. Every observation carves it, every model gives it contour, every failure makes it more specific. A specific silence is not the same as an empty universe. Not yet. One day perhaps, the silence will become heavy enough that the loneliness feels almost proven. Or one day, a signal will survive. It may be clean, or it may be damaged. It may be a narrow spike from a nearby star, or a strange persistent feature that takes years to understand. It may be nothing like what we expect. If that day comes, the work done during silence will matter. The false alarms, the rejected candidates, the plasma models, the interference databases, the archive reanalyses, the careful language, the refusal to overclaim. All of it will be the foundation that lets the discovery survive. A careless civilization might claim contact too soon and lose the truth in noise of its own making. A careful one may wait long enough to know. The galaxy forces patience. There is no shortcut across light years. There is no shortcut through noise. The signal, if it exists, must travel the full path. The search, if it is serious, must do the full work. At the end of another listening night, the telescope stops. The dish settles. The sky brightens at the horizon. The data are not dramatic. The world wakes, cars move. Phones light up. Human noise resumes across the planet that is trying to detect other noise from other minds. No message has arrived, or no message has been recognized. The distinction remains open. That open distinction is where the darkness lives. Maybe the universe is silent, maybe we are early, maybe we are late, maybe no one nearby transmits, maybe signals are too weak, maybe they are too rare, maybe they are too broad, maybe stars tear them apart. Maybe our instruments are listening through the wrong keyhole, maybe our filters are too strict, maybe the answer has never crossed our sky. Maybe it has crossed and died under the word noise. The question does not need to become a claim to be haunting, it only needs to remain possible. A small receiver on a small planet keeps listening. It listens through its own atmosphere, its own interference, its own fear, its own hope. It listens into a galaxy where stars do not care about messages and plasma does not care about meaning. It listens for a line that may never appear, or may appear too damaged to count. The universe does not have to be silent to keep its secrets. It only has to be difficult to hear. And for now, difficulty is enough. The screens fill with static, the data move on, the night returns. Somewhere in the black, a signal may not exist. Somewhere else, a signal may be traveling cleanly through emptiness. Somewhere else, one may be widening, weakening, losing its shape as it crosses the weather of a star. No human knows, no instrument knows until the wave arrives and survives the ordeal of detection. That is the final humility of the search. We do not listen to the universe as it is. We listen to what the universe allows to reach us, and to what our machines allow us to keep, between those two permissions, an entire civilization could vanish, not in fire, not in war, not in secrecy, in noise.